Okay. Tim, it's good to know you're making a mess of CentOS. I would like you to make a mess of AWS as well, because I think making a mess and then figuring that out is a great way to learn. So we can get started now. There's a lot of things that I wanted to cover in this class. So just to give you a heads up, we'll be wrapping up a few topics from the previous classes. We'll start out with something called S3 CMD, which is a command line tool to access data in S3. It's a very popular and common used tool, and I thought it'll be good to spend a few minutes on that. Then we'll be talking a little bit about CloudWatch, which is the monitoring service on AWS. If we get time, we'll be talking a little bit about DynamoDB, which is a highly scalable NoSQL database in AWS. Then I'll give you a brief overview of AWS API, and then we'll spend a few minutes on overviewing the other services on AWS. And then lastly, we'll be covering a bunch of miscellaneous topics that I wanted to cover at before the end of the course. So we'll get started with that. So before we get started, anything that you guys want to discuss from the previous class or any of the administrative things? How are your assignments going? Are you guys on track to complete? I think the first 3 assignments are due latest by 31st December. And have you guys have all of you taken the first 4 quizzes? Yeah, Aditya. I will be not yet had the chance to look at the assignment. I'll be doing it. I'll be starting it today, and I'll definitely give you feedback on the assignment. But I think generally the most important purpose of the assignment is to make you think a little more about the topics that we've covered in the class, as well as more importantly to implement some of those topics that we've discussed on your own. So if you've done that, I think that is the main purpose of the assignment. But I will review it and give you feedback. So just second. Tim, how are your quizzes and assignments going? Any things that you wanted to discuss on that? And why? So Tim, why are your assignments not not going anywhere? So Tim, are you finding any issues with the taking the quiz and the assignment? Okay, so this CentOS on your that's on your PC has lost networking. Okay, but you should be able to take the quizzes on your iPad as well, because for that you just need to access the SkillBrew application in a browser. Yeah, so Tim, can you at least take the quizzes on your iPad and uh, and I think we'll need to figure out a way uh, for you to do the assignments on. I think you need some kind of a PC running either Linux or Windows, or isn't there some kind of a SSH client application on iPad? Because I think that's the only thing we need, right? The SSH client application on iPad. So what do you need to do the assignment on iPad? Do you need anything more than an SSH client to connect to the uh, EC2 instances? There may be a SSH client for iPad. Okay, so I think we'll let's take this offline, but let me know how I can help you to get these infrastructure issues sorted out for doing the assignment. Because as I've told multiple times, the benefit of this course is only when you do the assignments uh, yourself. Just by me giving running through these slides is not going to cut it. That's not the objective of the course, or that's not what I want to achieve. Sure. So Tim, I think if you can get the laptop working, I think that'll be ideal. Okay. Um, so I think let's get started, and then I wanted to we'll get back to some of the other administrative things I wanted to discuss with you guys uh, at the end of the class. Yeah, just give me a minute, once again. Okay. So we'll so um, till now we've discussed all of the core services of AWS, and so today we'll be discussing uh, some of the slightly non-core things, uh, but popular and important things to give you an idea. So we'll start out with S3 CMD. So this is a command line tool for accessing data stored in S3, and as we discussed couple of classes ago, S3 is one of the most popular services of Amazon, and because it's a command line tool, it's well suited to be used in scripts, cron jobs, etc. And it's an open source project. It is not an Amazon. Uh, it's not a tool provided by Amazon. Rather, it's a third party tool developed by group of people, and it's open source. It's written in Python, and because it's written in Python, it can be used. It's portable and can be used on both Linux and Windows as well as Mac. And to install S3 CMD, first of all, you'll need Python. And I think last time we discussed installation of Python a little bit in the context of the AWS CLI as well, because that's also written in Python. And then you install S3 CMD using pip, which is the Python package installer. And then the first thing, configure it by running S3 CMD configure, where essentially you just have to give your access key and secret key, and then we are ready to use the tool. And here is a list of some common commands. So we can also see a demo, a quick demo, but essentially, for example, S3 CMD MB will create a bucket, RG will remove a bucket, LS will list the objects of bucket. Then S3 CMD put will put a file into a bucket. S3 CMD get will get a file from S3 into your local file system. Then delete, copy, move, all these commands are there. It's kind of similar to the Linux command line tools like copy, move, etc. One of the very popular tools of popular commands of S3 CMD is sync, and we'll talk a little bit about it later on. Then we can also compute the disk usage of a bucket, get info, set the access control list on an object, and so on. Okay, so sync is a very popular command. It can be used to either sync or get or put files between a local path and S3. Okay, so essentially, let's say if you want to keep a directory on your local file system in sync with an S3 bucket, you just you do a sync command. So yeah, PIM sync may be a standard Linux tool, but this is the S3 CMD sync command. It syncs files and objects between S3 and a local directory. Yeah, so the thing that PIM you are referring to is very different from S3 CMD sync, because S3 CMD sync will synchronize two directories, one on the local file system and the other one on AWS S3. Okay, and this is the website for S3 CMD, and after installation you can just do man S3 CMD to get the man page. Yeah, and then we can just quickly see a demo. Okay, so I already have S3 CMD installed. So we'll do S3 CMD help, and this gives the all the documentation. the documentation for S3 CMD. So let me try out a few commands. I'll do S3 CMD ls. So this will list all my buckets. And a question here: which region? So these buckets are being listed from which region? Global, right? So although buckets are specific to a region, and but SCCMD is it's smart enough to list all the buckets globally. And okay, let me just show you configure also. So when we do SCCMD configure, essentially we have to give the access key, secret key, and then there's something about the encryption password. If you want to use the encryption password between while transferring the file, there's a signing program you can use. Then it gives you an option to either use HTTPS or HTTP. Yeah, and that's it. The encryption is not configured, so that's fine. Okay, so that was just configure. Then okay, let's continue with the ls. So just ls gives the listing of all the buckets, and then we can go into any bucket and check it out in more detail. So let's do this one. So if I do ls on a bucket, it will show me the contents of that bucket, and then I can basically keep going down into the bucket directory, and it will keep giving me one by one the listing. And let's try to get a file from one of these buckets. Let's see this bucket. I think this is this year's bucket. Okay, so let's try to get one of these files. So I just do get on that file, and we'll copy it to the local directory. So essentially, it has we can copy files to S3, copy files from S3 to the local file system, and things like that. So I think that's just a basic demo. You can look at the S3CMD man page, and whenever if you do start using it, definitely start by looking at the help and the man page to understand more about what this tool can do. Okay. Anything else that you guys want to discuss about S3, or else we'll move on? Okay. So next, yeah, Aditya, S3 versus EBS. What do you mean? S3 and EBS are two very different kinds of storages. Okay, so it's not really possible to say which would be better. Rather, they're very different. They have very different use cases. So EBS is block storage. It is attached to a single EC2 instance. So that you will use it for let's say when you deploy the WordPress application. So the WordPress code would be served out of the EBS volume. However, on the other hand, S3 is not block storage. It is something called object storage, and its use cases are more like internet use cases, like uploading and downloading documents. So you can get and put entire documents or log files. Then S3 is also like a shared storage that you can access from any number of instances. It is much more scalable. So for example, I think EBS, the maximum size of an EBS volume is 1 terabyte, but in S3 the maximum size of an object is 5 terabyte, and then S3 is also more scalable. You can put many more number of objects and many more number of requests to S3. But that said, S3 is not high performance. Like it's not when you let's say if you want to request just one part of a file or one block of a file, then S3 will get you the entire file, and it will not be as fast as a block storage like EBS. So it's not really possible to say which is better because they're very different. But EBS is something you attach to an EC2 instance, and it's like a local file system. So like when you have your PC, you have a local disk attached to your PC. EBS is like that. Versus S3 is some kind of a remote, low performance but very high scalable storage and very high reliability as well. So if you're interested in this question, I strongly encourage you to answer this. I think in assignment 4 there's a question on comparing S3 and EBS. So and it's an I think that question has 2 options, and this is one of those options. So I'll strongly encourage you to take that, try to answer that question, because they are just different. It's you can compare them, but you can't say which is better because they have different use cases. Yeah. So for example, in S3, to access S3, we need to use these HTTP commands like get, put, post. So it goes about the HTTP protocol. So Linux cannot access S3 directly because Linux, talks what the POSIX files is the POSIX APIs. They cannot talk to S3 directly. So they need a local file system, which is the EBS. Okay, but I think if answering that question, doing this, I'll strongly encourage you to do your own research on this question because it's important to understand this. And if you have a doubt, take up that question in assignment 4 and do this comparison of S3 and EBS, and I'm sure that that'll give you more clarity on the fact that they are very different. They have different use cases. Okay, so let's go on with CloudWatch. So I think we've seen CloudWatch a little bit during this course, but we've not really talked about what it is. So we'll just briefly talk about CloudWatch. And essentially CloudWatch is the monitoring service for AWS resources. And what does monitoring mean? So the service collects, analyzes, uh, it helps users view the system and application metrics, and these metrics can be used to make operational and business decisions. So for example, when you're monitoring an EC2 instance, CloudWatch will report a certain predefined set of metrics like the CPU usage, disk IO, network IO, and things like that. And CloudWatch supports all the services that we've seen so far, like EC2, RDS, autoscaling, DynamoDB, EBS, and so on, and more. Most of the services in Amazon are supported by CloudWatch, and there are two variants of CloudWatch. There's a basic monitoring and a detailed monitoring. Basic monitoring is free and it happens at 5-minute intervals. So every 5 minutes we can get these CloudWatch metrics from the resource, and it only supports predefined metrics. And we'll see an example of these predefined metrics on the I think in a couple of slides. Then detailed monitoring occurs at 1-minute intervals, but it is chargeable. It costs 50 cents per metric per instance per month. So on an EC2 instance, there are 7 predefined metrics. So if you enable detailed monitoring on an EC2 instance, it's going to cost 7 into 50 cents, which is $3.5 per EC2 instance per month. And it also supports custom metrics. So you can define some custom metrics and connect it with the CloudWatch as well. Okay. So before doing this, let's see a demo. I think that'll make it more concrete about what we are discussing. So let's go to let's first see an EC2 instance. I just click on the instance, and below there are these tabs. So I just go to the monitoring tab, and it's showing me that CloudWatch alarms. Okay, so we'll talk about CloudWatch alarms later, but essentially these are the 7 metrics. So CPU utilization, then disk reads, so disk read in bytes, disk read in number of ops, disk writes in bytes, disk writes in number of ops, network bytes, network out bytes, and status checks. I to be honest, I don't understand why memory is not part of this. So because memory usage is a very important metric, but for some reason it's not part of CloudWatch by default. Now, so this was EC2, and we'll also, let me show you for RDS. For RDS, there will be a different set of metrics. Okay. Yeah, so on the top there's this tab called a button called hide monitoring, show monitoring. So it's showing CPU utilization, then number of DB connections, freeable space. I don't really know what that is. Write IOPS, read IOPS, right? So these are the, and I think there are more metrics. So if you click view all CloudWatch metrics, it will show more. Okay, so this is the CloudWatch panel, and here we can see the RDS metrics. So in RDS actually there are many more metrics. So let's see for, so we will just filter on one of the RDS instances, which is this one, and there are some 13 metrics, right? So and we can select on it to see the graph over time. Now, one second. So anyway, so these are bunch of metrics related to the database essentially, or related to relevant to the database. Okay. So every service has its own set of metrics, and these metrics come in these two variants for the basic monitoring and the detailed monitoring. With basic monitoring is 1 minute intervals and detailed is 5 minute intervals. Okay, then there's this thing called CloudWatch alarm, which is, let's say your you want to create some action when the CPU usage of your instance goes beyond 90%. So in that case, you can create a CloudWatch alarm where Amazon will send you a notification when the particular event happens, and based on these alarms, it's possible to take automatic actions or manual actions, like even Amazon can take a very specific actions, like Amazon can stop or terminate an EC2 instance, or it can add and remove EC2 instance from auto scaling group. But you can grab this notification and you can take any other action that you want. Okay, so we will see an example of creating an alarm, but some of the use cases are sending an email to the administrator based on very high CPU usage, then stopping or terminating an idle instance. So for example, and this can be done directly inside AWS. If AWS finds that an instance is less than 5% usage, you can have an alarm that automatically terminates it. Stopping web servers with unusually high traffic, because many times unusually high traffic could mean some kind of attack on the web server. So in that case, you may want to stop it. Stopping an instance with the memory leak. Although I don't know, I have to check because memory, I'm not sure if memory usage is supported by CloudWatch. Then we've already seen in auto scaling that based on these CloudWatch metrics. Yeah, Tim, anything? Any question? Tim, can you hear me? So we've already seen Tim, can you hear me? Or others? Aditya, Ankit, Priya Ranjan, can you guys hear me? Okay, Tim, I'll try to speak a little slowly so that it's better. So we've already seen when we discussed auto scaling that it's possible to have this auto scaling policy where instances either get added or removed from the auto scaling group based on certain events. So that happens through CloudWatch. Basically, CloudWatch creates an alarm and then the auto scaling policy acts on that alarm. Okay, so let's quickly see an example of an alarm. Okay, let's let's do it in on an EC2 instance running in Singapore. So let me just refresh this page. Okay, it's not working. Try it again. Yeah. So let's see EC2 metrics. So let's take so first let's click on CPU utilization, and this will give the graph of the CPU usage. And then we can see either the average, minimum, maximum, some different variants of the metric, and yeah. So in our case, the granularity will be 5 minutes because I only have basic monitoring. So, but we can select the granularity from here. If you want, let's say if you want to see it on an hourly basis, you can do that. Then on the right side, you can select the time range you want to see for what range of time, the last 1 hour or 1 week, whatever. Okay, now let's go to alarm. So the alarm link on the left menu, and we can create an alarm. So for creating an alarm, I need to select a metric. So we'll just use CPU utilization on my instance, and so see that I have to choose. When I'm configuring the alarm, I have to say that CPU utilization on a particular instance. No, it's not possible to say that. Let's say I have a farm of 10 servers. So and I want a alarm on each of those 10 servers. So in that case, I have to create 10 alarms. I cannot say that I cannot just create one alarm which applies to all the 10 instances. So what I'm trying to say is that I cannot create an alarm which says that send me an email when the CPU utilization of any of these 10 instances goes beyond 90%. Rather, I could create 10 different alarms, one for each instance. Okay, and then you have to give a name. So if my CPU utilization is greater than 90%, and then again, like we saw the auto scaling policy, there is this notion of how many periods. So the CPU should be high for how many consecutive periods before the alarm happens. So I'll say just one period, and then when this alarm happens, there are three types of action. So, look at the action box at the bottom of the page. So the three types of actions are either you can send a notification, or you can do an auto scaling action, which is essentially add or remove an instance from the auto scaling group, or you can take an EC2 action, which is terminate or stop the instance. So we can just look at these. So send notifications. I'm going to send notifications to this, and essentially this is going to send me an email. Then EC2 action can be either I can stop this instance or terminate this instance. Okay, and auto scaling action will not apply here, but in the case of auto scaling group, it could be either add or remove an instance to that group. Okay, so this is essentially the CloudWatch alarm. Now, what I feel about CloudWatch is that it's a good basic low level monitoring service, which means because and because it's very low level, like I give you an example where I have to create a CloudWatch alarm for every instance separately. I can't have a kind of a higher level logic in place, and because of that, it's not very easy to use, especially when we are dealing with a large setup or in a very dynamic environment where servers come and go every a few hours or few minutes. Because when there are a lot of servers coming and going, essentially you need to create more alarms, create and delete alarms, and so on, which makes the managing the alarms themselves quite difficult. And I personally feel there are opportunities to offer higher level monitoring capabilities on top of CloudWatch alarm, CloudWatch metrics, and there are already companies who are trying to do this, but this is definitely an area where things can be made easier to do. So Aditya asked this question: is there any way we can cause the CPU utilization to rise? Yeah, of course there is. You can just write a script that does nothing. So you want me to do that? Okay, sure. Let's try it out. So let me first connect to my 82 instance. So I'm just connecting to my 82 instance. Okay, so connected. Let me just I've just started something called screen. So this gives me multiple shells, and we're just going to monitor the CPU usage. Okay, so let's try to increase the CPU. So let's see if this will work. Uh, the CPU has gone up to about 50%. It's not 100%. Okay, so let me try something else. Let me just create a C infinite loop C program. Okay. What's what's wrong? Okay, so yeah, now the CPU is more than 90%. So let's see. Let's go back to our alarm. One second. So what do you want me to do? Do you want me to stop the instance? Okay. So it will send me an email and it will stop the instance when, right? So it send me the notification and stop the instance, and let's create the alarm. Okay. So let's get back to this after 5 minutes, because it'll take 5 minutes uh, for the next next set of metrics to come, and then the alarm to take this action. Okay. So let's get back to our CloudWatch. So essentially, I feel that CloudWatch is good, but it can be a little difficult to use because it has to be used on every resource. So when you have a reasonably complex system, you'll have many resources, and then using CloudWatch on all of those devices can be difficult, and especially so when you have a lot of dynamics in your system. Then here are the references for the CloudWatch page on Amazon and the documentation regarding CloudWatch. Okay. So that is with CloudWatch. Anything that you guys want to discuss on CloudWatch? Yes, Aditya, there are alternatives. Like there are other monitoring services. For example, I think Nagios is a popular monitoring service for servers. So if you're just interested in EC2 instances, then there are alternatives. But when it comes to, for example, RDS, for example, then there cannot be any alternatives because uh, RDS is a managed service that only AWS has control over. Yes, so only CloudWatch can report RDS or ELB, the Elastic Load Balancer. That's the managed service provided by AWS. Uh, so for those kind of services, CloudWatch is the only option. So what you can do is you can use CloudWatch and build higher level or more easier to use monitoring capabilities on top of CloudWatch. I think that's the way to think. And then yeah, for EC2 instances, there are other monitoring metrics, the other monitoring tools. Then another category of monitoring tools is application monitoring. So this CloudWatch is mostly around the the infrastructure monitoring like CPU, memory, disk usage, and so on. But let's talk in application. So let's say you're running a web application. You want to know things like how many errors did you have, or things like that. So that is not reported by CloudWatch at all. Yeah, I am not very familiar with preable memory. I think Tim knows about it. Okay, so I think okay, I see some activity on our console. So if you see that the alarm has become red here, which means, and there's a 1 next to it, which means the alarm is active, or the alarm is in state alarm. The other states are okay or insufficient. So let's see if this has stopped my instance. Okay, so you see that the instance has been stopped now. Okay, and let me also see my email. I should have got an email about this. Okay, for some reason I'm not seeing the email. Let me just check why I'm not seeing the email. Yeah, so it should have sent me an email. Maybe we'll just wait another few minutes and see if the email comes. But currently I've not yet got any email. Okay, so yeah, it's coming from the US, so that's why it's taking a little bit of time. So let's get to the next thing I wanted to cover. So just we wanted to quickly talk about DynamoDB because so this is one of the more recent services from Amazon. It was launched only in 2011 or 12, but it has become very popular, and you know we will see a little bit why it's become very popular. Uh, so what is DynamoDB? It's a fully managed NoSQL database, and so there's this big there's this huge shift happening in the database industry right now. Because for the last 20 years people have been using only relational databases. Either Oracle or Microsoft SQL, MySQL or Postgres or some of the other ones. But essentially all of these databases are similar in nature. They are relational. Now in the last 5 to 8 years or so, with these internet scale applications like Facebook, Gmail, this very huge applications, people have found out that, or people are finding out that these relational databases don't scale. They become the bottleneck for the application, and because of that, the whole architecture of databases is undergoing a huge shift. And one of the alternates to relational databases is something called NoSQL. It means not only SQL. Yes, SQL is a international standard on how to access relational databases. But in the last 5 to 7 years, NoSQL databases of different types have become very popular, and the most fundamental reason for them becoming popular is that they are much more scalable uh, compared to relational databases, uh, and they're more scalable because, for example, they can be easily scaled out by adding more hardware, whereas relational databases are not very easy to scale out. So DynamoDB is one type of NoSQL database. NoSQL means that the tables do not have fixed schemas. So in a relational database, you will define a table which has, let's say, 10 columns, and then every row in that table will have those 10 columns. You can't say that some rows have uh, you know uh, 20 columns, but other rows have only 5 columns. So those kind of things are uh, not possible. So relational databases have essentially fixed schemas. Yes, you can have null cells or null columns, but that's a different thing. You essentially it's a fixed. Uh, so with NoSQL you don't have uh, fixed schemas. Rather, uh, any object or any row can have any number of data items, any type of data items that it wishes. So I'll not go into much detail about NoSQL. If you're familiar with this topic, great. If you're not familiar, consider this just as an introduction. Just be aware that there's a great shift happening in the database industry, and uh, for a lot of use cases, especially the high scalability use cases, NoSQL databases are becoming very important and very popular. And DynamoDB is a managed NoSQL database, which means managed means that Amazon offloads the administrative burden of the database from the user of the application. Yeah, so Pim, the records don't need to be fixed length because NoSQL doesn't have fixed schemas, and this also includes the length of the record. So different, you know, there's no maximum length of the record as such. But even NoSQL, there are many NoSQL databases popular right now. I think yeah. At the end of this slide deck, I have a few examples of NoSQL databases, and there are at least 10 popular NoSQL databases, and there are many more NoSQL databases that are out there, and they all have slightly different characteristics and things like that. Yes, MongoDB, InnoDB, no, InnoDB. I've heard of it, but I'm not sure if that's a NoSQL database. I'm not very familiar with InnoDB. Cloudera. Cloudera is something very different, Aditya. Cloudera is related to Hadoop. Cassandra, yes, Cassandra is a NoSQL database. Okay, so InnoDB, if InnoDB is similar to MySQL, then it's essentially a relational database. Okay, so managed, right? So in the way that RDS was a managed relational database, DynamoDB is a managed NoSQL database, and all these NoSQL databases they support this get put operation using the primary key. The primary key is often called the object ID, and then you can query on the primary key. So they support these three basic operations. You can get an object based on a primary key. You can put an object given a primary key, and then you can query on the primary key. And then yeah, so DynamoDB has a maximum item size of 64 KB. So also wanted to note that this is DynamoDB is more relevant to application developers, because so DynamoDB is something like it comes in the category of like a platform as a service, because okay, so let me take that back. But to use DynamoDB, the application has to be modified to use the DynamoDB rather than some other database. And so this topic is more relevant for the application developers amongst you. Okay, now here this slide talks about some of the unique aspects of DynamoDB. So firstly, it uses SSDs or solid state drives, and because of this, it's fast. Then the data is replicated across the availability zones, which as we've seen in the case of EBS and S3 and RDS, this really increases the data availability and durability. Then this is a very scalable service, which means that Amazon splits up the data and traffic among a large number of servers, enabling it to handle a very high request capacity. So it's highly scalable. And then DynamoDB SDKs are available in at least 3 languages: Java, .NET, PHP. I think there will be more. There will also be other SDKs in other languages as well. But officially, it's available in 3 languages. Okay, so if you are an application developer, when would you want to consider DynamoDB? So you should consider it if your application needs a large, highly scalable schema-less database. So if you know that you need something like a NoSQL database and something like MySQL or Oracle is not fitting your needs, then you look at a NoSQL database and then look at DynamoDB. And okay, to configure DynamoDB, you just need to specify a desired performance objective. We'll just skip this for now. Okay, the important point is that this is the developers need to code against DynamoDB, right? Uh, so the way this decision happens is something like this. While you're developing the application or designing the application, you figure out that you figure out that a relational database is not working out, not scaling. So you make a decision to go with a NoSQL database, and then after that you decide that there are a bunch of NoSQL databases. Should you use like open source database, or should you use DynamoDB? And then whichever database you decide to use, the developers have to code against that database, which means that if you are using DynamoDB, you are essentially locked into it to a certain extent. You can't move that application out of Amazon. Pricing is again, it's a little complicated. We're not going to detail here, and it's essentially split into two things. There's a price for the provisions throughput, and there's a price for the storage itself. Again, as I said, DynamoDB alternatives are NoSQL databases, such as this slide has some of the popular NoSQL databases like MongoDB, Cassandra, Redis, CouchDB, HBase, which is used in the Hadoop ecosystem, and then React. So these are just the popular ones. There are at least 15-20 more which are not very popular, but they also exist. Again, here are the references for DynamoDB. With that, thank you. That's the end of this DynamoDB. Okay, and I'm checking my email, and for some reason I've not got any email from that CloudWatch alarm. I don't know why, because in the past I have set up some alarm, and I do get emails, but this time I haven't got it. And it could be a configuration problem that we don't have the time to go into that in more detail, but at least what we saw was that the instance was stopped. Okay, so can we quickly talk about AWS APIs for 10 minutes, and then we can have a break? So this is also, I'm just going to give you an overview. I'm not going to get into too much detail. Okay, so firstly, it's important to remember that all AWS services can be accessed via APIs, and in fact, these APIs expose the most low level, they expose all the possible options of the service, which may not be available via the console or the CLI, right? And just as an introduction, what is an API? So an API is essentially a application programming interface. It defines how two software components interact with each other. So APIs relate to software components, and they are not user interfaces. So in the sense that you don't expect end users of a system or a application to be using these APIs. Then APIs are a specification that a client software can use to interact with the server. So in our case, AWS is the server, and the client software could be an application that you write or something like S3 CMD. So S3 CMD is using the S3 API to communicate with the Amazon S3 service, and the definition typically includes things like the on-wire protocol for the request and response, the resource on which the action is taken, then the status codes to inform about the status of the action, whether it succeeded or failed, if it failed, why did it fail, and so on. Okay, so I hope this is clear. So AWS APIs are so as I said, all AWS services can be accessed via APIs. The AWS API is a web API, which is essentially, this means that it uses HTTP as the transport, and it allows the software components anywhere in the internet to interact with each other. And we've already discussed that the APIs expose all the possible controls on a particular service. Then AWS uses APIs use the XML format for the request and response. So I'm sure that some of you will be familiar with XML, and we'll see an example of this. And obviously, to interact, to use these APIs, we need the access key ID and secret key. So this is how we tell Amazon our identity. So who am I? Who am I that's making the API call? Okay, and this is an example. So this is an example of so we'll have to read it a little in a little detail. So just give me a second. Yeah. So essentially, this is an example of the API, and this is a HTTP post request. So there's post here, and then slash is the URL in HTTP. So these are some details, and if you're not, even if you don't understand all of this, it's fine. Just remember that it uses HTTP. Then these are all the HTTP headers here. Okay, this is when I'm passing the AWS access key ID, and then the action is describe instances. So if you remember, when we were doing the CLI, there was a command called EC2 describe instances. So this is that command basically. Now then there's the signature method, signature version, and timestamp. So timestamp is obviously yes, using Telnet we could see this, but this is essentially the capture of the on-wire exchange. So this is the exact thing that goes on-wire when we make this API call. So timestamp is the time on which the API call was made. Then this is the version of the API, signature. So let me just talk about signature, because that's a tricky part here. So the signature is essentially it verifies this API request by signing it with the secret key. And on the server side, Amazon will again verify this signature by decrypting the hash, by decrypting the signature, and making sure that this is a authorized API request, and computing this signature is is just it's a little complicated. We will not go into details, but and you can see that there are a lot of these fields that have to be sent, and the signature is a little complicated because we have to take certain fields from the request and then encrypt it with the secret key and so on. So it's a little tedious process. And then there are also all these headers. So let's say if I'm not very familiar with HTTP and I'm not very familiar with what the hell these headers mean, I'm gonna find it hard to make these API requests. Okay, so what is the solution to this? Okay, before that, okay, we can also see the response. So again, this is HTTP. These are some of the headers, but the rest of the stuff is just basic XML. Yes. So as Prem is saying, the signature is verifying that it's actually you who have made this API call. So it's used to authenticate the API call. Okay, so this is the response, which is XML. So let's go on. Yeah. So these APIs are not very easy to use, and that's why AWS provides SDKs or software development kits, which make it much more easier to invoke these APIs. So let's look at SDKs. So what is an SDK? So an SDK is a set of software development tools that make it easier to develop more powerful software. So that's the definition of SDK. And SDK is a piece of software. Like an API is more like a specification. That the client has to make the call in a certain way, so that it will be understood by the server. But the SDK is an actual piece of software. It's not just a specification. And typically SDKs implement APIs or libraries or frameworks. So Amazon provides SDKs that make it easier to call the Amazon APIs, and essentially these SDKs contain the client-side implementation of the AWS APIs. And these SDKs come in a variety of languages like Java, PHP, Perl, Python, Ruby, C#, C++, .NET. They also come for a variety of environments ranging from Windows, Linux, iOS, Android. And using these SDKs, developers can work directly in a programming in language environment that they are already familiar with, rather than all this HTTP and signing and HTTP headers and all of that. We don't have to worry about all of that. Rather, you just work in work at a much higher level of abstraction. And as developers, we don't have to deal with low-level API details. So let's see an example of this SDK. So this is an example of the. Okay, so it's a different API this time. So this is an example of the Python SDK, and even if you're not familiar with Python, that's fine. But what the key point that I want you to appreciate is that this looks much easier to do. It's at a much higher level of abstraction compared to the APIs. So in this case, the first command is connect to a region. So it's connecting to a particular region. In this case, it's US East 1, which is North Virginia, and then the second command or the second statement gets all the instances running in that region, and then it just prints that the list of those instances on the console. So this was much easier to do than figuring out all the HTTP headers and then signing the request and so on, right? So which one should you use? So you'll almost always use an Amazon use the AWS SDK rather than the on-wire API directly, unless the only kind of exceptional cases are when you are implementing an SDK or when you are working in an environment for which you don't have an SDK. Only then you would use an API. Or there's another situation where sometimes using the API can be higher performance than the SDK. So unless you are in one of those kind of exceptional situations, you will almost always be using the SDK. Okay, and then there's important question of when should you use the AWS APIs or SDK. So essentially, when you need to automate tasks related to the AWS services, or you want to build additional capabilities over AWS, and the CLI does not provide the desired level of flexibility or power that you want. And to use the APIs or the SDK, you need to be comfortable with programming in any of those languages. Okay. So with that, so this is the list of so this is a link to the API documentation and the SDKs from Amazon. And with that, that's the end of this slide deck. So any thoughts or any questions on APIs or SDKs? I know we've just we've just briefly gone over it very fast, but if you're going to be using if you're going to be building some complex systems, then you may end up using these APIs, and they are not very difficult to use if you know any of those languages like Java, Python, Ruby. So if you are comfortable with them, these APIs are very easy to use. So any thoughts or questions on Amazon APIs and SDKs? Okay, if not, then let's take a break for 10 minutes. So it's 4:30 on my clock, so we'll start exactly at 4:40. Right? Okay, guys. So have your tea, coffee, take a restroom break, and let's reconvene at in 10 minutes. Okay. Thanks then. So let's have I think last 45 minutes of this course. So as you know, this is an introductory course in Amazon Web Services, and so we've not. So what we've done is essentially go over all the core AWS services so far, and but I wanted to share, just give you a brief overview of the many other services of AWS, so that you should have at least some idea of what are the other services out there, and what's possible to do. Um, so you just have a little bit of an idea about that. So that's what this session is about. Okay. So before we get started, can you guys please list out the core AWS services that we've discussed so far? So tell me, what are the services? So just tell me what are the important or core Amazon services that we discussed. Yes, EC2, S3, RDS, auto scaling. To use auto scaling, we need to use so we need to use something. How do we send the traffic to an auto scaling group? ELB, right? Right. CloudWatch, right? So CloudWatch is the basic monitoring service, and then along with EC2, we discussed the storage options, EBS and ephemeral. So essentially, these are what you guys have listed. These are, in my opinion, the core services. Yes, Elastic IP. That's a good one, Pim. Right. So whatever you've listed is correct, and so these are the core services, and these are the services that you'll probably use first, or you'll start with AWS with some of these services. But AWS has many other services. So we've discussed maybe 6-7 of them in detail, but AWS has at least 20 other services on offer, and this slide just lists out those services. So in deployment and management category, there is IAM, which is a very important service, and we talk about it in this session. There is CloudFormation. We'll talk about CloudFormation briefly. CloudTrail is a very simple service that records each and every call made to AWS. So whenever you start an EC2 instance, you just record that call. Whenever you access an object in S3, it will record that call. So this the data captured by CloudTrail can be used for something like auditing or diagnosing, if it's finding out who did what and things like that. OpsWorks, I think we'll talk a little bit about OpsWorks also. Elastic Beanstalk is something like a platform as a service capability in Amazon. It allows administrators and application developers to deploy complete applications stacks, and but however, to some extent, Elastic Beanstalk is similar to OpsWorks, and maybe it's being superseded by OpsWorks to some extent. Then in networking, Route 53 is the DNS service from Amazon. So if you don't have a separate, so you can use the Amazon DNS service, which is supposed to be more scalable and more integrated with the Amazon services. VPC, Virtual Private Cloud. So that's a very important service, and we'll talk about that in more detail. Direct Connect is a networking service which allows a high speed connection to AWS. It's used by companies to access their servers in AWS faster from their corporate locations. In storage and content delivery, we'll talk a little bit about CloudFront, which is the content delivery network CDN service of Amazon. We'll talk quite a bit about storage gateway because that's one of my favorite services. I think it's a very high potential capability in Amazon. Then in terms of application services, cloud search is some kind of a search service. I'm not very familiar with it. Then we'll talk briefly about SES, which is the email sending service, and SNS, which is the notification service, SQS, which is a queuing service, and SWS, which is a workflow service. So these application services are, again, they are more targeted to the application developers rather than infrastructure managers or administrators. Then there are few services for analytics and big data. EMR is Elastic MapReduce, which is essentially Hadoop on cloud. It makes it very easy to create and manage large-scale Hadoop clusters on AWS. And then data pipeline and Kinesis are a couple of other services which we'll not be talking about in more detail. For database, there is Elasticache and Redshift. So Elasticache is an in-memory cache, high, very scalable in-memory cache. If you're familiar with Memcached, it's something similar to that, but much more high performance and scalable. And Redshift is it's a new service launched by Amazon, I think in 2012. It's a data warehousing service for very large scale of data. So if you have huge amounts of data and you want to provide some kind of a service on that, like cataloging or searching through that data, then Redshift is the service to do that. So next we'll be talking about few of these services that in a little more detail, but again it's just like a couple of slides on each service and nothing more than that. So as with so all AWS services essentially share the same pricing formula, which is no upfront fees, and it's a completely pay-as-you-go model and pay only for what you use. Moreover, most of the management services are available at no extra charge. So we'll see services like CloudFormation, Elastic Beanstalk, so these services essentially manage your application rather than they don't provide any resource as such. So these management applications don't there's no charge for them. Okay, so first let's talk about IAM, which is the Identity and Access Management Service. It's a very important and very powerful service. So this is how you all have been given accounts. So you all can use my account to access Amazon. So essentially, IAM enables multiple users to use a single account, but with their own separate credentials. So all of you have your own username, access key, and secret key, and so essentially you have your own credentials. But we are all sharing the same AWS account. Moreover, in the way I've configured the IAM account is I've given only certain specific permissions. So for example, I've only given permission to launch micro or small EC2 instances, and if you try to launch a bigger instance than that, you will get an error. So those are the kind of things we can do in IAM. So the features of IAM are we can assign ready-made permission templates or create your own permissions. So Amazon provides certain ready-made permission templates, like there could be in an organization there could be different people who are managing. For example, one person could be managing the EC2 resources, and another person could be managing the S3 resources. So these two different people will have different permissions, so that they are they can only do what their the EC2 guy cannot interfere on S3 and things like that. So we'll see a demo that there are a bunch of ready-made permission templates, or we can create our own template. And for example, for this course, I went and created our own set of permissions, because none of the ready-made templates were doing exactly what I wanted. Then it's possible to configure very fine-grained permissions, where with every permission you can specify things like the service, the region, the action that you're performing on the service, and the exact resource. So you can go down to the exact resource ID, for example the EC2 instance ID, and you can have resource level permissions as well. It's possible to organize users in groups, so which I've done. For example, I've created a group with all of you, and then I've applied a permission on the entire group. Then there's also role-based access, where you can configure different roles and set the permissions according to the specific roles. Now, because IAM is like a management service, and it doesn't like have a resource that we're using, there's no extra charge for using IAM. And then there's the link to the IAM at the bottom. So let's quickly see a quick demo of IAM. And I just want to do this because it is I feel that IAM is one of the important services, and you guys may end up using it when you work on Amazon. So here is the IAM dashboard. So on the left side it lists it has links to the group, users, roles, identity providers, and so on. So even IAM actually allows you to also integrate with Google sign-on and Windows Active Directory sign-on. So where, let's say, if a company is using Windows Active Directory for their authentication system, they can connect that with the IAM service. And there's a lot of stuff you can do, but we are just going to cover the basic, some of the basic things. So let's see. So I'll just show you what I've done for this class. So there's a group, and then that group has 12 users. It has a set of permissions. Okay, and when I click on the group, we can see that the users in this group. Then we click on the permissions tab, and it shows. So these are all the permission policies that I've attached to this group. Let's just look at one of the permission policies. For example, so one thing. Let me see. Can I find it now? Let me just copy out this policy. Yeah. So I hope you guys can see this policy. It's a dark background, but I hope it's visible. So these policies are in the form of JSON, and this policy these policies can involve a lot of detail, but I think this is not a very complex policy, and that's why I'm just showing it to you. So there's a version, there's a some there's a bunch of statements on the policy. Then there's the effect, which is essentially, does the policy allow or deny? Oh, sorry, does this statement allow or deny? Then the action refers to what was the action being requested. So here it's star, which is a wildcard, but the action could be, for example, a particular, for example, it's the start instance or stop instance. So those would be examples of action. Then the resource is we are identifying the resources on which this statement is applicable, and this is this is essentially, it's a list in JSON, and what this list of resources, essentially it's saying that so ARN is it stands for the Amazon resource something. It's basically like a tag for the Amazon resource. Then AWS refers to the it just refers to AWS. The next thing, the third one, is the service, AWS service. In this case, it's EC2. Then the next one is the region, and I think the next after that it's the I forgot what this is, and then the list of instances. So essentially this policy is for I put for blocking any actions on EC2 in all regions except North Virginia. So it includes all the regions except US East 1. So remember, I had sent you an email saying that I blocked all regions except North Virginia, just to make my life easier. So it's any action on any EC2 resource in all of these regions. Okay, and the same thing, I have another policy statement block which is doing the same thing for RDS. Okay, so essentially that's the policy I put, and if you just get a gist of it, that's fine. The important, the key takeaway is that it's possible to implement such policies, such granular policies when you want. Okay, now let's look at some. So let's try to look at some of the pre-configured policies from Amazon. So we'll try to attach another policy, and so this is the pre-configured policy templates. So administrator access, which is it says it gives full access. Then power user access gives full access except to IAM. So a power user cannot add new users, but he can do anything else. Then read only access. Then there's something for cloud formation, read only access. Cloud watch. There are service level accesses. So there's about 100 pre-configured policy templates. Then next there is a policy generator. So this is something that I used when I was creating the policy for this course. So this helps you create a permission policy essentially. So here you configure the four main components of a permission policy, which is the effect, whether it's allow or deny, the AWS service that we are going to use. So it lists all the service, and we can choose only one. Then the actions. So here it will list all the actions possible on an EC2 instance. Okay, and then the Amazon resource name. So let's say I want to deny on EC2. I want to deny there's a run instances. So run instances is the API to start an instance. So run instance and start instance I'll deny, and then my resource name is star. Okay, and then we add this statement. It's also possible to add certain other conditions like if the the resource is looks like this or looks like that, and based on the some of the keys and values. Okay, so so this will essentially it'll generate a policy, and this is the it can also show me the policy in JSON, and if I want we can customize the policy again here and then apply it. Okay, so this is a lot of detail I know, but remember that the gist is that it's a IAM is a powerful feature allowing you to configure what permissions you want to give the multiple users on the AWS account. Okay, so we will proceed from here, and we will just quickly talk about cloud formation. Right. So so here's the thing. So last class we looked at some of the common use cases with Amazon, and specifically some of the common application deployment use cases. And when we were deploying an application, there were a bunch of different resources or different services that we have to use. Like we have to have use EC2, then auto scaling, then ELB and RDS and CloudWatch. So any significant deployment will use a bunch of different Amazon services. So and if you want to set up all these services on your own, it's essentially a tedious task. And more importantly, let's say if you want to set up these services, and if you want to somehow automate the task of setting up these services, you essentially have to write your own script. So Amazon has a bunch of services to simplify the task of creating this non-trivial deployment setups, and CloudFormation is one of those services. So CloudFormation helps to create and manage a collection of related AWS resources, and with CloudFormation we built something called a deployment template. And so for example, I can create a deployment template for deploying a web application, or let's say a WordPress application, and I can reuse that template as many times as I want, right? So that's essentially the benefit of CloudFormation. You create the deployment template once, and then you can reuse it any number of times. Amazon also provides a bunch of sample templates, and we can adapt our own templates from them, or we can create our own templates. The downside is that these templates can look quite complex, which which we'll see. And because again this is a management service, it's not really like a resource. There's no extra charge for CloudFormation, and then let's see an example of CloudFormation. Okay, so this is the link from the slide, and so these are the sample templates. So there are a bunch of Windows, SharePoint, Active Directory templates, then there's a template to set up Drupal on a EC2 instance. So single EC2 instance with local MySQL, or you can select RDS and so on. So so there's a bunch of templates. You can set up a simple LAMP stack running PHP Hello World on a local MySQL database or RDS or multi-AZ RDS and so on. Then auto scaling. There are there are examples of auto scaling, and lot of the stuff S3, RDS. So a lot of the stuff that we've already discussed. Okay, so let me show you one of the most simplest templates. So so let's see So let's see this, a simple LAMP stack running a PHP Hello World application. Okay, so this is the actual CloudFormation template. I'll just zoom in a little bit. So again, it's specified as JSON, and even if you're not familiar with JSON, that's fine. Just try to get a gist of it. And it has a bunch of things. So there's the template version, description of the template, the parameters, where you can configure the DB name, the DB username, and so on, right? And then there's a section on resources, what are the resources used by this template. So essentially, it's creating a web server, which is an EC2 instance, right? Then it's going to install these packages via yum. So this is not only managing, like the virtual machine. It will also install. It will go into Linux and install packages using yum. So this is the list of packages. Then I don't know what is sources, but this looks like some kind of a file system path. So I think this looks like copy copies this zip file from S3 and put it at var.html. Then there's a MySQL configuration. So we'll run a MySQL database on this EC2 server itself. Then here we are configuring the MySQL daemon to be enabled, and the HTTP daemon, which is Apache, to be enabled, and then a bunch of other things. But essentially, and it's configuring security group options, like it's configuring the website URL, things like that. So yeah, so essentially, so in this template we specify what is the EC2 instance, what is the image, what is the Linux services that we want to be running, and we can also configure these services. And Amazon will just take this template and launch it, and we'll have the whole system up and running. The only downside is that you, as a developer or system administrator, we have to understand this language, this specification language for the CloudFormation. But once we understand it, it's it's very powerful. But if you don't understand it, it looks I think it looks difficult. But once you understand it, it should be simple to use, or at least it should be very powerful once you understand it. Okay, so that was an example. How do we launch it? So Aditya, you can launch it using the CLI, or you can even launch it from the so see, in this case we can just launch it from this button on the right, but in general you can go to the cloud formation. Uh, you can go to the cloud formation section in the console GUI and create a new stack. So uh, give a name and use an existing template. So I think we were looking at simple PHP hello world. So that is not there, I think. So we can just you can just do upload template file and then just upload the template file and then follow the steps to launch it. Now one thing, yeah, so let's actually do this. So while launching, it will also give options of a number of launch parameters. So let's save this file. Okay, so let's save this file. Then let's okay. So I've given the template here. Okay, then I go to the next step. Yeah, so here so see, in the template specification there were a bunch of parameters provided, parameter section. So all these parameters are can be configured from the next step. These are so essentially what I'm saying is that these are not hard coded into the template. Amazon will allow you to modify these parameters uh, while launching the template. So for example, DB name. So we'll look at this one. So we can modify DB name. So it shows that the default is my database because so the default my database is given, but we can modify it while launching. So I think so that's an important thing that I wanted to show via this example. Okay, and I think if I so we have to so you guys want me to go ahead and actually launch it. I think my key name was test01. So okay, I'm not going to configure any notifications. So I've just launched it. Right, and so the parameters can be configured, and there are a bunch of some things cannot be configured. For example, the AMI. So it's using a hard-coded AMI depending on a particular region, and I think in this case it's going to use the Amazon Linux AMI. Now, just one question. So this template has a table which has the mapping of region to AMI. So depending on which region this template was launched in, the AMI is selected accordingly. So why do you think this mapping is there? Why can't we use the same AMI irrespective of any region? No, it's not because of IAM rule. Like, so I'm the super administrator for this account, but still, those I have to use this mapping. So can I use the same AMI in, let's say, North Virginia region and California region? So let me see if it has created a EC2 instance. I see this rollback, which is a little uh, weird. So there, so it has not yet created the EC2. So it's possible that something has gone wrong. So it looks like something has gone wrong. Yeah. Uh, so something has gone wrong, and I'm not sure how to figure out what went wrong. But essentially, it has just deleted all the resources that it created. Yeah. But anyways, I mean, this it failed. I think this time. But I hope you get the gist of the idea that you can create a complete application stack or a complete system setup and define it in a cloud formation template, and then use that template to launch that entire uh, system. And then you can also uh, stop that entire system in one shot from this. You can just click on this delete stack, for example, and stop that entire stack. Yeah, I mean, I don't know. Something went wrong. What went wrong is it's not. I don't know where to look. What to debug what went wrong, but something has gone wrong. Oh, I think it's here. So this key pair failed because I gave an existing key pair name, and that failed. Something failed. So just let me check what is the name of my key pair, because I think I gave the wrong key pair name. Okay, so my key pair name is actually Pavan dash SG. So let me use that one. I'm sorry, this was a. I'm just going to delete this tag, create a new tag. I'm going to say Pavan SG this time, and let's see if this goes through. Okay, so I think we'll just check back on this in another 5 minutes. Till then, let's go ahead. So that was cloud formation. That's it's something like a higher level or in a PaaS level kind of tool, because it allows you to manage uh, a bunch of resources together rather than individually. Now similarly, there's another tool called OpsWork, which is a more recent tool, but this also, I think it has the same idea. It allows you to manage uh, launch, delete, stop an entire application stack, and this has uh, it defines the stack in certain concepts. Like there's something called a application stack. An application stack is made up of a bunch of layers. For example, the load balancer could be one layer, auto scaling group could be another layer, and RDS could be another layer, and so on. Then there's your app, which is the code. So it can get the code from some services like GitHub and or any Git server and deploy it. Internally, it uses a DevOps tool called Chef to deploy and configure the software components, and it can also take custom Chef recipes or to as part of your deployment. And again, because this is a more of management tool, there's no extra charge for using it. Okay, so there's no demo for that. We'll just continue. So we'll just talk a little bit about VPC or virtual private cloud, and this is a very important service, especially if you're going to deal with the corporate customers, because VPC allows you to provision logically isolated instances or sections inside of AWS. So by logically isolated, it means that nobody can connect to your AWS instance using a public IP. So if you notice, all the EC2 instances that we have created so far have had a public IP address that anybody from the internet can connect to. But with a virtual private cloud, it's in a separate network where by default you cannot connect to it from the internet. So it's like a private virtual private network, and inside this private network you can use your own IP addresses. So for example, if your corporate has a certain um, it uses certain private subnets, in some IP address range, you can extend that subnet to the Amazon VPC cloud, and you can have your own IP addresses, your own set subnets and network gateways and so on. to connect to a private cloud, you need a VPN service. So you can set up a VPN service to connect between the private cloud and your data center. So this will mean that only only from your corporate VPN or your corporate office you can connect to the virtual private cloud, and not from any other place on the internet. And we'll see a diagram of what you can do in the private cloud next. But essentially, when you launch an EC2 instance, you're given this option of whether it should be inside a VPC or not. And if you create it in VPC, then it won't have a it may not have a public IP address. It can, but it doesn't need to. And but for launching these EC2 instances inside the VPC, there's no extra charge. But if you are using the VPN service, so a VPN, Amazon provides the optional VPN service as part of VPC, and if you're using that VPN service, it's 5 cents per hour. Okay, and here are the sample connectivity diagram. So in this diagram, on the left side is our virtual private cloud inside Amazon, and on the right side is our corporate data center, and they are connected to each other using the VPN connection. And they have inside the VPC, it can have its own virtual private gateway. So this is a service provided by Amazon. You can have your own routing service. Again, this is a service provided by Amazon. You just need to configure it. Then this diagram is showing 2 different subnets in 2 different availability zones. Right. Yeah. So if you're dealing with corporate clients, then there's a good chance that they'll be using VPC, because and what are the reasons for using VPC, or what are the use cases, is the higher security deployments. So for example, using VPC, you can create a setup where you have a public facing web server, but everything except the web server is in a private is in a virtual private cloud, and the networking is configured so that only the web server can connect to the database servers and things like that. So this would be a more secure deployment versus putting all our resources outside of a VPC, which will mean that anybody can connect to the resources, as long as it's within the security groups. Now, from corporate point of view, there's another very important use case, which is to extend the corporate network into the cloud. So, for example, in our first class we talked about something called cloud bursting. So, cloud bursting essentially means that let's say I have a application. So let's take a simple application like the wiki application, and what's happening is my wiki is getting overloaded, because it's getting too much load. So as an administrator, what you can quickly do is create extend the wiki application in the Amazon cloud. So basically, by putting, you can dynamically put in more resources from the Amazon cloud, and have a VPN connection between the Amazon VPC and the corporate network, so that even users from inside the corporate network go to the Amazon VPC transparently. They don't feel any impact. So there are many use cases around extending the corporate network into the cloud, and for this, the de facto mode of deployment would be a VPC, because you want it to be secure. Okay, makes sense? So I know, again, we are not going into too much detail. I'm just covering it at a high level, but the expectation is that you get a gist of it, and then when you actually use these services, for a real world uh, use case or for a client, then I think you'll be able to then at that time you can go into the more specific details of the service. Okay, now I think let's quickly take a look whether our stack is up. So yeah, it says create is complete, and let's go to the EC2. So it's showing me another EC2 is running, which is the the one from the cloud formation stack, I assume. Yeah, it's from the cloud formation stack. Okay, so we'll just let it be right now, but let's actually connect to this instance. So we'll see that it has a web. We should see a hello world page, right? I'm just going to connect to it. Yeah, it's showing me, I think, the default some PHP info page, right? So we can see that our cloud formation stack is up now. So sorry for that configuration glitch in the key name. I think apart from that it went fine. Okay, quickly, I'm just quickly going to talk a little bit about CloudFront. So CloudFront is the content delivery service from Amazon, and essentially a content delivery service is used to distribute content to end users with low latency. So we've already discussed this use case a couple of times, and this is essentially done by using the best suited edge location. So depending on where the user is physically geographically situated, the best edge location is used by Amazon to serve the content. Amazon has 49 edge locations worldwide, including in India, and compare this to only 9 I think 9 regions, right? The origin server for CloudFront can be either a S3 bucket or EC2 or non-AWS. So we'll see what is origin server in the next slide. And the pricing is essentially you pay for the data transfer charges. That's it. Okay. So here's a pictorial representation of CloudFront. So you see that the origin server is shown in the middle, and around that there are a bunch of edge locations. So depending on where the user is geographically, the content will be served from a different edge location, more suited for that particular user. And okay, so this slide we see how it works. So the user makes a request to the CloudFront, and it is routed to the best suited edge location. Yes, so Pim, you're right. So it's like a proxy server. Proxy come cache. It's not just a just a simple proxy server. It does more because the edge. So the edge location will attempt to serve the request with the local copy of the file. So if the edge location already has that file, it will serve it. But if the local copy is not available, CloudFront will get a copy from the origin server, and then this copy will be served from that edge location server. Okay, so this is the sequence of steps for serving data from CloudFront, or for that matter any content delivery service. Like for example, you may have heard about Akamai. So Akamai was one of the pioneers in the content delivery market, and it's still I think Akamai is still a very strong player in that market. Okay, next I'm going to talk about Amazon Storage Gateway, and as I said, this is one of this is one of my favorite services, and I spent about 6 months ago. I spent a lot of time investigating it in more detail. Uh, so essentially, so Amazon Storage Gateway is a hybrid storage. Is hybrid storage. It combines local storage in your own office with cloud storage, and we'll see what are the benefits of doing that. But essentially, this is the deployment picture. So on the left side is your own data center or your own office, and on the right side is the Amazon cloud. So the storage gateway consists. So we'll talk about the left side first. The storage gateway. So Amazon gives you a storage gateway software, which is essentially a virtual machine image, and you deploy this virtual machine image in a VMware server. And so Amazon is just giving you the software, and you have to add the you deploy it in a VMware server, which means you're using your own hardware. Then you connect your own disk to the server and so on. And Amazon, and then you can create volumes on this storage gateway. So a volume is essentially a unit of storage. It's some, let's say, 100 GB of storage. Now what happens is you start adding your data to this local volume, and this volume will automatically get backed up on the Amazon cloud. So what will happen is that the storage gateway virtual machine will take periodic snapshots of the data. So let's say you can configure that take snapshots every hour, and then every hour it will upload these snapshots to the Amazon cloud, and basically it will upload it to the S3 service, right? Yeah, it's not mirroring. It's more like a backup. So every 1 hour, backups will be taken on the storage gateway virtual machine in your office, and they will be uploaded to the Amazon S3 service. Now, so you have your backup. So let's see what happens. So let's say there's a problem with your office. Because of some reason, your entire storage gateway virtual machine is crashes. Okay, so in that case, what you can do is restore from the backup in S3. So from the backup in S3, you can create an EBS volume, which is shown on the right side, and then just attach this EBS volume to an EC2 instance and access your data. Okay, so that's the sequence of that's how this storage appliance works. So essentially, what you're getting is or okay, let's go through the slides. But I hope so we have 2-3 slides on this, and I hope it's starting to make sense. So storage gateway is hybrid storage service bridging the corporate data center and the AWS cloud, and it consists of 2 components. As we talked about, there's the local component, which is the storage gateway virtual machine with your own hardware, or with your own disks and CPU and memory and so on. Then the second component is the AWS cloud, which is the S3 and Glacier service essentially. So the local storage gateway provides volumes that can be mounted as iSCSI devices, and even if you don't understand these terms, it's fine. Just understand that these storage volumes can be attached to a server, and they can be used as to store data. So because it's local, it's in your own office, it gives you very fast LAN storage. That's the key point. Okay, because if you were storing data directly on S3, it has to go over a wide area network and it will be slow. But with storage gateway you get combination of very fast LAN storage plus the high durability and backup of the cloud storage. Okay, now so you get fast LAN storage from the local volumes, and then the storage gateway periodically transfers the data to the cloud in the form of snapshots. And these snapshots, in the case of a disaster or some problem, these snapshots can be restored in AWS. So they can be restored either to an AWS volume or they can be restored to some other storage gateway also. Okay, so the use cases are essentially high speed local access for the storage. Okay, and we will talk about frequently accessed data in a bit, but essentially it's high speed local access to the storage combined with infinitely scalable and highly durable cloud storage. The second use case is it can be used to automatically back up to a highly durable cloud storage. So which is the use case I was talking about initially. It automatically backs up your data every hour to the cloud, and while providing you LAN speed storage. So I think that's great. And then it can be used to quickly restore data in the cloud. Yes, so it comes. This storage gateway can be deployed in pre-configuration. We will not. Let's not talk about the virtual tape library. Only the first two. So the first one is gateway stored volumes, and the second one is gateway cached volumes. We'll see the difference. So gateway stored volumes. Essentially, so again, the left side is the data center, and the right side is the Amazon cloud. So in a gateway stored volume, the storage gateway virtual machine essentially creates a the backup. It's only backing up to the S3, and we contrast this with the gateway cached volume. So gateway cached volume has a slightly different use case. So this is where, let's say you need 1 terabyte of storage, but you have your disk size in your office are only 100 GB. So caching will happen. So what the storage gateway will do is store the most frequently accessed 100 GB of data in your office and store rest of the data in S3. And whenever you access whenever you access the cached data, it is served locally. And when you access a piece of data that is not cached, the storage gateway virtual machine will go to S3, get the data from there, copy it to its local drive, and then serve it to you. Okay, so this is it acts like a cache. So now the beauty of this is that it allows you to store only the frequently accessed data in your office, and the rest of the data you are just storing in S3. But as a user of the data, it's transparent to you. You don't have to care about what is stored in storage gateway and what is stored in S3, because all of that caching algorithms and all are happening automatically. Okay. Yeah. So that was storage gateway, and I think the reason this is really I really like this is because obviously I come from a storage background. I've worked in storage for a long time, and I think this is where storage is going. The entire industry is going to move towards hybrid storage, at least for the SMB market. Small and medium businesses, they are moving towards hybrid storage. Then we've not talked about some other use cases. With hybrid storage, what also happens is you can share data across offices. So if you have branch offices, let's say 5 branch offices throughout the country, and you want to share data. How do you do that? So hybrid storage uh, allows you to do that. Although not exactly storage gateway. This doesn't support sharing the data, but there are in general, there are other players in the hybrid storage market that enable that. Okay, we'll quickly talk about few application services from Amazon. So SES is a simple email service. It's essentially a scalable email sending service. So email, sending emails is actually computationally it takes a lot of load on your server. So if you can use Amazon SES for sending emails, and essentially it means that you're offloading the email sending to Amazon. So you don't have to deal with all these send mail and postfix and all these other mail sending programs, and also you're offloading it. And this is actually, we are using SES for our mails from SkillBrew, and you may have seen it in your emails. Simple notification, SNS means simple notification service. It is used to deliver notifications to various types of endpoints, and the endpoints can be either an SMS or an email, or it can be delivered to a simple SQS, or it can be an HTTP endpoint. Now, when we had that CloudWatch alarm, it actually uses SNS. So the CloudWatch alarm sends a notification which goes to an endpoint, and that endpoint is configured to be my email address. So that's how it works. So just if you can just remember from your point of view that CloudWatch uses simple notification service, because that might be relevant for your work. But mostly all these services are application services, which means that again they are targeted more towards the developers rather than the systems administrators. Simple queuing service is a very reliable and highly scalable message queuing service, and it helps to build systems consisting of loosely coupled components. So we'll not go into much more detail, but it's essentially, let's say if you have two pieces of software, two applications running on two servers or whatever. So you can use SQS to send messages between those two software components. And the reality is that building queuing services is actually not easy, as an application developer. So it's, if you're building an application consisting of multiple components, it's and you want to communicate between those different components, it's very good if you use SQS, because it's a very robust service, whereas building your own is not. You have to address a lot of corner cases that arise in distributed computing. Okay, simple SWF stands for Simple Workflow Service. This helps build application workflows and business processes. And beyond that, we're not going to discuss it. SQS is a message queue, right? That's right, Tim. And the complicated scenarios come when your message queue has multiple endpoints. So, for example, your app 1. So I have two applications, app 1 and app 2, and there are 10 instances of app 1, and there are 10 instances of app 2. Now, when you send it, when app 1 sends a message to app 2, you want to ensure that only one instance of app 2 has taken that message. It should not be that two instances take that message, because that will lead to the wrong thing. So there are some of those corner cases that come up, and SQS already handles it, so it's a good thing. Okay, we'll quickly talk about elastic MapReduce. So essentially, EMR is Hadoop on cloud servers, and I'm sure that you may have heard about Hadoop. in some way or the other, because it's a very popular uh, software tool nowadays. But essentially, Hadoop helps process vast amounts of data, which is called big data nowadays, with a very highly scalable scale-out architecture. And this scale-out architecture can be done on commodity hardware. And this is the reason why Hadoop has become so powerful, because uh, first time in history, even small businesses have access to a software that can analyze large amounts of data at a reasonable cost. So essentially, EMR allows you to launch and stop Hadoop clusters, and you can quickly launch Hadoop clusters, going up to tens or hundreds of machines or even thousands of machines in a few minutes. And that's essentially what EMR does. And because with Hadoop you end up with this large number of instances, because you mostly you're dealing with a lot of data. So you end up with a lot of infrastructure, and EMR essentially helps you focus on your application, your data processing application, rather than managing that humongous infrastructure. Okay, so that is EMR for you, and this is a sample pictorial depiction of EMR. So EMR is designed to input and output data to S3, and then you can use CloudWatch again to monitor the EMR cluster and then take whatever action and things like that. But essentially, the key point to remember is that EMR is the Hadoop on cloud service, and it can be used to quickly launch very big Hadoop clusters, launch and destroy. And what also happens with this Hadoop use cases is that many times you just want to run them for 6 hours. You don't want, or even 1 hour. You want to run a small job for 1 hour on 100 instances and then tear it down. So EMR will do that for you. Okay, I think with that, that's the end of this slide deck. So can I take this 10 more minutes of your time, and then I'll let you go. We'll wrap up after that. This is the last slide deck where I just wanted to cover a few miscellaneous topics that that I think are important. So first of all, there's a correction around EC2 reserved instances. So I told you that the instance type of EC2 reserved instances cannot be changed once they are reserved, and this was a major gripe I had against reserved instances. So what I found out from by talking to one of the one of the AWS solution architects is that this is wrong. There is a way, in fact, to change the EC2 reserved instance type after it's been reserved, as long as you are staying within the same instance family. So there's this notion of EC2 instance family, which an instance family is defined by the ratio of memory to CPU. So let's say small and medium are in the same family, because I think small has one CPU with 1.7 GB of RAM, and medium has 2 CPUs with 3.4 GB of RAM. So they have the same memory to CPU ratio, so they are in the same family. So what you can do is you can both split and merge. So if you have one medium reserved instance, you can split it into 2 small instances. Okay, and you can also do the reverse. You can merge 2 small instances into a medium instance. Okay, so I just wanted to clarify this. Okay, then I wanted to quickly talk about two very important use cases that we didn't talk about in last hour. So one is on the data lifecycle management. So it's possible to configure data lifecycle rules in S3 and Glacier. So essentially, the rules are of two types. So reserved instance. Remember PIM, we talked about reserved instances in the second class, where it's essentially a trade-off between upfront cost and running cost. So if you you can reserve an instance for 1 year by paying, let's say, $100 upfront, and that will reduce your per hour running cost for the EC2 instance. No, PIM, you don't remember? Maybe you missed that class. But essentially, reserved instances provide this trade-off between upfront and running cost. On-demand instances are simple. Upfront cost is 0, running cost is high. Reserved instances, there are 9 kinds of reservations. Okay, we discussed reservations in, I think, class number 2. So then 9 kinds of reservations, which is very complicated. There is this light, medium, heavy, and then so actually there are 6: light, medium, heavy, and then there's 1 year and 3 years. So there are 6 kinds of reservations, and depending on the type of reservation, you can have very high upfront cost and a very low running cost, and combinations in between. Okay, so coming back to data lifecycle management, so it's possible to say in S3 that move all objects that are more than 1 month old to Glacier. So do you remember? Do you guys remember what's the difference between S3 and Glacier? Have I put everyone to sleep? Yeah, PIM, that was discussed in class number 3. So if you missed that class and did not watch the video, you should. Glacier is cheaper, right? And so basically, Glacier, how cheap is it? Cold storage. It's so let's not say cold. It's for archiving. Yeah, archival is the right word. So archive storage is something that you don't, kind of the storage is there, but you don't expect to access it. It's only there for a very exceptional kind of disaster kind of case where you will need that data often. Sorry, where you will need that data. Yeah, not even less often. It's like very rarely you will use that. Very rarely. Okay. So and the reason is the cost. S3 costs 10 cents per gigabyte versus Glacier costs 1 cent per gigabyte. So you can have an archival policy, for example, that move objects that are more than 1 month old to Glacier, and this will help save you cost. You can also have a deletion policy saying that if your objects are more than 6 months old, just delete them from either S3 or Glacier, wherever. And these are not one-time actions; they are policy rules, which means that once these rules are configured, Amazon will automatically monitor your S3 bucket and perform these these lifecycle management actions on objects in that bucket, right? So it's something like every day Amazon will look for objects that are more than 1 month old, and whatever it finds will move to Glacier. So it's a recurring operation, and this is it's very simple to configure also. So we'll quickly see that. So just go to S3. and click on go to some bucket. So I'll just go to test. Okay, so my bucket is empty, but so I clicked on properties on the top, and then here there's a section called life cycle. So you can add rules, and your rule is essentially then you can say apply to either bucket, entire bucket, or you can apply it only to a certain prefix, certain folder, and then you can specify the time that uh, it can either be from the object creation date, or it can be effective from a certain calendar date. And then there are essentially two actions. Either you can move it to Glacier. So I'm going to add two rules. I'm going to add these rules to my entire bucket, and I'm going to say move objects more than 30 days to Glacier, and objects that are more than 180 days delete them. So expiration basically it means delete on expiry of this period. It means that the object is expired. Okay, so this is all. This is the only thing we need to configure, and then save it. And there's a warning. That's fine. And that's it. That's done. So this is really powerful to. It helps you manage your cost, because for example, in previous client projects, what we've done is we've had a particular, for example, in the backup use case. So for a client, we were backing up their data periodically to S3. So we use this policy to move old backups to Glacier and to delete very old backups automatically. Okay. Okay. Then the next use case I wanted to talk about quickly is application update. So we talked about this deployment scenario in the last class. This is the scale out deployment architecture within a single availability zone, right? So there's a ELB. The ELB is serving traffic to an auto scaling group. Yeah, and somewhere there's a database and so on. Now what happens? I want to upgrade the application now. So there's I've got the next version of the application. I want to upgrade it. So if I can do it one EC2 instance at a time, right? But many times when I'm upgrading, I want to upgrade the entire auto scaling group in one shot. Make sense? I want to upgrade the entire auto scaling group in one shot. So the way to do that is in parallel to this, I will create another auto scaling group with the new version of the application. Okay, and this initially it will be, this auto scaling group will be idle. Now once this auto scaling, the new auto scaling group has been created, I will just change the ELB configuration to start serving the traffic to the new auto scaling group. Okay, so I create a new auto scaling group with the new version of the application, and second step, I just switch the ELB configuration to serve traffic to the new auto scaling group. That's it. And by doing that, the whole auto scaling group is updated at once, which is cool. Okay, and we'll just talk just few more slides, a recap of AWS benefits. So just to remind you, ELB is Elastic Load Balancer. That's the Amazon service that distributes network traffic among a bunch of EC2 instances. Okay, so the key properties of AWS, just to remind you, are that all the services are elastic, and there's very elastic and scalable capacity. So elastic means you can string your capacity up and down very fast. scalable means you can go up as much as you can, as much as you want, because Amazon has thousands of servers or more at your disposal. Quick and easy deployment. We've seen a lot of demos in this class. You've done your assignments also. You've seen that it's very quick and easy to use most of the services. There is no capex or initial investment for using any of these services. All of them are pay as you go and only pay for what you use. And there's a lot of automation and reusable components. So you can create, for example, we saw a great example with the cloud formation, where you can create reusable components and then use them again and again to launch that setup. And then automation, you can automate all of this using either CLI or APIs. So what are the based on these properties, the key business benefits of AWS are lower IT costs. These lower IT costs come from a variety of factors, but essentially it means it's because there is lower. You're not managing you don't have to buy your own hardware. You need lesser manpower to manage and so on. Now, very importantly, AWS allows you to focus on your own application and business rather than the IT infrastructure. So basically, we need fewer resources or fewer people to manage the IT infrastructure. Yeah, no write-off on the capital expense, I guess. So Amazon allows you to. It helps you take focus away from IT infrastructure and onto your application and business, because it simplifies the IT infrastructure management. Because of this, because you're focusing on your application, you have a faster time to market. You can go to market with new features, new applications faster. And then last benefit is that you can go global with a world-class experience without any capex, because so AWS has this world-class and global infrastructure at your disposal. You can use any of that without any investment. The top use cases for AWS cloud are, I think we may have talked about this, are web applications. There are thousands and thousands of examples. Here are just two of the popular ones: Dropbox and Pinterest. Media applications. Netflix is a very popular service in the US for serving movies that is completely served out of Amazon. Enterprise applications. So we have seen features like storage gateway and VPC, which are very enterprisey features, and a lot of enterprises are using Amazon more and more, like Shell and Samsung. Then a lot of this big data work is happening on Amazon, because for big data you need a large cluster, and Amazon is very well suited for that. Because with services like Elastic MapReduce, you can quickly create and destroy clusters and very easily. And then archive and disaster recovery. This is one of the first use cases of the cloud. Because S3 is the most popular service for archive and disaster recovery, because you can store your backups on S3 and you can store your archives on Glacier. Okay, then I just quickly wanted to talk about some of the best practices around AWS. These are simple things, not very complicated, but I think if you use them in your when you work with AWS, it'll be good. So firstly, you should always use EBS as the root volume for EC2 instances. If you're going to use ephemeral or instance store, use that very carefully and only for temporary data, only for data that you can afford to lose and reconstruct. Don't use ephemeral for any important data or any data that is not very easy to reconstruct. You should use elastic load balancer for load balancing between EC2 instances. So it is better to use an Amazon service like ELB rather than to use your own software. Like for example, some of you may be familiar with something called HA proxy, which is a load balancer for traffic. So instead of that, use ELB because it will make your life easier. So auto scaling is one of my most favorite features because it's so simple and so powerful. So use auto scaling for automatically scaling EC2 instances depending on load. Use RDS instead of your own database because as we talked about, database is a is the most critical thing in your application architecture because you can't afford to lose your data, and RDS makes it much simpler to manage your database with features like multi availability zone deployment and read replicas, which if you try to do on your own will be very difficult, or you may not even ever be able to do it because, for example, for multi AZ, Amazon uses its own technology to achieve that feature. The multi AZ is not supported natively by the database. Then for if you are looking for high performance, use provisioned IOPS feature in EBS. So this is available in services like EBS, RDS, and DynamoDB. So provision your IOPS according to what level of performance you want. And then if you want high availability, replicate your application stack in at least 2 availability zones in an active setup to achieve high availability. So we've already seen a use case of this in the previous class. Use S3 for static content. So S3 is very popular and used by millions of people world over. So use S3. It's a very highly reliable and scalable service. So use it for your data, but be clear on the difference between S3 and EBS. Use CloudFront for edge caching and serving content with lower latency to your users. And for disaster recovery, it's important that to back up your data to a different region. So it's good if you back up your data, let's say from your primary region, for example, North Virginia. So create a backup in a remote geo like California or Singapore, just in case there's something, just in case the whole data center goes down. And because these backups are not very expensive, you can just back up your data and store it in S3, and it's not going to be very expensive. You just need to create maybe a bunch of scripts for that. Okay, the last best practice is around. So we've seen a lot of AWS services now, and many of these, these services are at different points in the stack. Some services apply to the application, some services apply to the to the infrastructure layer and so on. But the more AWS services you use, the more benefits you can expect to achieve. And but the downside is that you get, the more AWS services you use, the more locked in you get with AWS. So you have to balance this trade-off, especially if you're an application developer or maybe even an IT consultant. But that's the trade-off you need to balance. Okay, and then last slide. What I feel are the opportunities with AWS for you and for me. So at high level, I see 3 ways to use AWS. Yes. So Tim, you're talking about OpenStack. So in what context are you talking about OpenStack? So OpenStack is a very promising and very promising cloud technology that can be used to create your own clouds, and I think it's great, but yeah, OpenStack is definitely OpenStack. Yeah, I think it's a competitor of AWS, but also I think they have slightly different use cases. So AWS is more about the public cloud, whereas OpenStack I feel is more about creating your own clouds, either public or private, and then so as a company could create its own data center using OpenStack. A second use case is a service provider could create its own cloud using OpenStack and then provide cloud services on that. So yeah, I think they are competitors, but AWS has great scale. So that's the thing. You have to trade off. You have to figure out whether it's better or worse for you to use more of AWS. On the better side, you get a very powerful service. On the downside, you get more locked in, and so you have to assess this on a situation by situation basis. Okay, so let's talk about what you can do with AWS. So at a high level, there are three ways to use AWS. So one is if you are an application developer, you can deploy your application on AWS, and by doing that, you get the economic and you get economic benefits such as low running costs, no capex, as well as technology benefits like high scalability and high availability. So that's if you have your own application. But I think most of you guys are not in that category. So the next two apply more, which is if you are so you can provide more value added. So you can provide managed services on top of AWS. So what I mean by this is, so AWS is at the infrastructure as a service layer. It has a lot of scalable services, but these services are not very easy to use. So we need people who are expert in systems administration, systems management in AWS itself to be able to provide managed services on top using AWS. Okay. The next thing is, the third one is where we identify that so for example there are many areas where AWS is not easy to use. So you can create your own applications or tools on top of AWS that add value by making it more easy to use the AWS infrastructure. So for example, you could provide these benefits to your clients either in the form of an application or in terms of tools and processes that make it easier, or which allow you to add more value to the application deployment. So these are some areas, and I am definitely very personally I'm very interested in the third one, in how we can make it how we can build more powerful and easy to use tools on top of AWS. And if feel free to let me know if you're interested in that area. And I'm also very interested, and we can if you have any opportunities of working together in that, definitely we would like to explore that. So with that, so local dashboard, yeah, I mean, so I have a lot of complaints around the AWS dashboard. Like it's tied to a region, but what if I wanted AWS dashboard that is tied to a service? So for example, I want to see all my EC2 instances running worldwide. There is no way in the AWS dashboard to do that. The AWS dashboard will only show me what's happening in a particular region in a single page. So there are many many ways to do that. Okay, so Pim, what I was saying is the AWS dashboard, the console is tied to a particular region, because so let's go to EC2. No, Aditya, you cannot customize it. No. So at the top you see North Virginia. So it means that I am working in the North Virginia region. Let's say I wanted to list all my EC2 instances running worldwide. So I cannot do that easily using the AWS console. Yeah, Aditya, by customizing means so you cannot customize this itself. You'll have to build on your own, because this AWS console is not a open source project. It is intellectual property owned by Amazon. Yes, you can build your own dashboard using the API exactly. And once you start using AWS, you'll see that there are many such opportunities uh, to make things easier to use or make things more powerful in some way, like CloudWatch. I think there's a bunch of work to be done on CloudWatch. I don't think it's a very easy to use service. Yes, using SDKs, and these SDKs thankfully are very easy to use. I've worked quite a bit on the Amazon Python SDK, and that's very easy to use. And I know from looking at examples, I know that the Java and Ruby SDKs are equally easy to use and very powerful. Right. Yeah. So with that, guys, we come to the end of the course, and uh, so now something very important. I would we really need your feedback on this course, uh, which will tell us how we are doing, how we've done in this course, and which will help us improve in future. So I sent out the course survey form couple of weeks ago, and I would really appreciate if all of you can take that survey and provide your frank and honest feedback on this course. Yes, Tim, I saw your feedback. Thank you very much for that. And I really, I really need you guys to be honest and frank here. If you didn't like this course, if you thought it sucked, tell me. Because otherwise we will just not know, how we are doing. So please tell us what we are doing well, and what ways can we improve. It is vital. Your feedback is the most important takeaway for me from this course. So please, and this feedback is completely anonymous. It's up to you. If you want to keep it anonymous, do it. If if you're comfortable sharing your identity, do that. But that is the most vital takeaway for me from this course. So please, really request you to provide your feedback. Okay, and beyond that, I would really appreciate if you guys can take your quizzes and assignments on time, because that's the whole philosophy behind what we are trying to do. We are not trying to come here and give lectures. This thing is the classes are only a initiation point. Beyond that, we feel that the best and only way to learn is by doing it yourself. So please, you have been given this, you have been given access to the console, APIs, everything. So please try out things on your own. I've been, to be honest, I've been disappointed with some of the things, like in the last two classes we've had very less attendance for class number 4 and 5. I don't know why. So 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 please, uh, so anyways, so do your assignments, quizzes, and I'm always available. So I've been a little disappointed with the amount of interaction we've had on things like the forum or email or things like that. Only except couple of people. most of the class has not shown any interest in asking questions or trying out stuff. So that is my feedback to you. And most of those people are not present in this class, but that has been disappointing. That the level of interaction on the forum and things like that has been very low. But if there's some if there's a reason for that, and if that reason is attributable to me, tell me. Give me feedback. Really, I need your feedback to help improve this course. Okay. So more case studies once in a while on your website. Sure. As we go along, we'll do that. But I want to be very frank in admitting that we have a very small setup right now. We don't have too much bandwidth, and we are trying to bootstrap something which is hopefully valuable. But over time, definitely, you can expect more relevant blogs, case studies, videos, a lot of free videos, things like that from SkillBrew. But for that I need your help. I need you to tell me how to make this course better and more valuable for in future instances, or tell me from here what next. So we've had an introductory level course on AWS. What are the next topics that will be relevant to you? Because there's a bunch of I can think of creating a course on each service of Amazon. It's possible to do that, because every service has a lot of details and things like that are very relevant when you actually start using that service. Yeah. So give me feedback. Basically that's I'm just requesting you to give us honest and frank feedback. Please don't be diplomatic or shy or hide the bad thing. Be brutal. Okay. And yeah. Anything else that you guys want to discuss? So Tim, many Indian culture is like many people end up being shy in India because of our culture, or either shy or diplomatic. People don't always share their honest feelings in public. That's my opinion. Yeah, be brutal. No problem. Because that's how we'll learn. That's how we'll improve. But be honest. More than anything, be honest and share what you feel. Okay, and feel free to connect with me anytime. During so we have another week or so for this course to do the assignments and things. But anytime, I'm always available. I'm also, I would love to explore any collaboration opportunities with you guys. So Tim, this is the last class. So please feel free to reach me anytime. That you have my email address, you have my phone number. I hope you feel that I'm accessible. If I'm if you feel otherwise, please let me know. Okay. Anything else that you guys want to discuss? Any feedback that you want to give me right now? Okay. So there's nothing else. Thanks, Aditya. I know we rushed through a lot of the things, in today's class, but I didn't want you guys to end this course and feel that you don't even know 70% of you don't even know anything about 70% of the AWS services. So I think the approach in this class has been to cover the core services in detail, but cover this do an overview of most of the other services as well. Yes, yeah, Pim, what do you want to know about OpenStack? So we are trying to do a course on OpenStack, but OpenStack itself is a huge huge piece of technology and software. Prereqs. I think it will be the same as this course. Basic understanding of computer architecture. Basic understanding of things like networking, storage. Because all this cloud and all, it kind of covers a lot of different things, but an introductory course would go over each of those things in a little way. Like we go through a little bit of storage, a little bit of networking, a little bit of administration and management. Yeah, but I think so Pim, if you want OpenStack, I'll also try to find out good references to OpenStack. I'm sure there may be some quality videos on things like YouTube, and I'll try to find them for you and share with you. You may do it today, Tim. And by the way, OpenStack can also be installed on EC2 instance. So I know people who've done that. I've not done it myself, but I know people who've done that. So if you want, install OpenStack on a medium instance, and do it today. Like there's nothing preventing you, I think, or there's nothing that you need to wait for. But again, there's on the business side, there's this huge shift happening in how data centers are created, and OpenStack is a big thing in that shift. Future data centers will be built using technologies like OpenStack. So it will be a great investment for you. In the same way that Amazon Web Services, AWS should be a great investment for you guys. I hope this course will be a good investment for you, and you will be able to actually use it in your career or business. Okay, so I think with that, let's break up. Let's we obviously keep in touch. I'll keep troubling you on the assignments and quizzes and the feedback surveys, and we'll be in touch at least for another week or so, and then beyond that, feel free to reach out to me anytime that you want. For people who are in Bangalore, if you want to meet up sometime, we can do that, or if you want to drop by our office sometime, let's do that. Okay, so with that, bye everyone. Thank you. Have a great new year, and have a great career and life ahead. But I do look forward to interacting with all of you again. Okay, thanks a lot. Hope you enjoyed this course. Take care and bye.